In this particular video, we are going to write the test bench of the device that we just designed, and the test bench really just allows you to test the different devices, to test the device that you created. For example, if you have your unit under test device here, if you have your unit under test device, like what we just created, we have the test bench, and this device basically has multiple inputs, and then it also have outputs. So the test bench wraps around this particular device, inputting different inputs to this device and analyzing the output, and basically tells you how your unit under test or device is functioning. So now let's write this particular test bench, and to do that we first of all need to have our inputs, and we can get that from the different inputs inputs and outputs that we have for our device. We must first of all declare them as signals, which will be declared here in between the architecture of the simulation and begin. And so you can simply copy and paste them here, and this is why I like using Visual Studio, because it allows me to do things like this. So we must have them as signals, and since they are signals, then they don't have inputs or outputs. We are declaring them as signals, and okay, so we have the signals, and the next thing, we first of all need to declare to know how fast our clock is going. And so to do that, we have constants. We must write constants first of all. Of our clock frequency, and this is in terms of an integer. The type is an integer, and we can give it like, for example, 1 microsecond. Let's give it 1 microsecond, and our frequency is, we also need to define our frequency, which is going to be in terms of time, and our frequency is simply going to be our this is our period, not frequency, our clock period, which is going to be our clock frequency divided by, this is going to be 1 second divided by our clock frequency. So this allows you to have your clock period. So after doing this, then we have other things. For example, we need to define our unit under test device here to instantiate it, and you instantiate it by doing this entity work .diff flip-flop with enable, and we have it in our RTL. Alright, then we come and find our ports, our port map. Right, and our port map is this one's right here, and okay, and we also need to define our clock. So not define our clock, but associate our clock. So we'll say clock equals to not clock after our clock period, This allows you to basically toggle within half a period, and then you're going to have your clock period being the entire clock, right? And having said that, don't forget to instantiate your clock, to initialize your clock with an initial value of, for instance, 0 or 1, then so that we'll be able to toggle. So then after that, we can define our test process. Great. And since we are using VUnit, since we are using VUnit, we need to declare a few. We need, in our test bench, we have to put some libraries also from VUnit, such as, and these are the libraries. And then we also need to use this right inside the entity. We need to use that, and also we will have to have our test runner inside our main process, which is right after the begin. And also we need to have one at the end, which allows us to clean up or close the runner, the test runner. So then we write our code, our test process inside here. Okay, and so to do this, we are going to write, for example, we're going to have, let's just have, let's wait, first of all, for, well, let's have D, and let's say our D is 1 in this case. Okay, and well, actually before that, we can first of all reset. Yes, we say reset can get 1. Okay, and then we can wait. We can wait for 1 clock cycle. Yes, or which is going to be 1 microsecond. Yes, our clock period. Okay, so this is going to be our clock period, and then we can say reset equals to 0. We can also say that this is going to be our input equals to 1, and then we can wait. We can wait a clock period, and we can wait for 2 clock periods, and we can say that we can change our D to be equal to 0, and we can also say that our enable, in fact we do not have any enable here, we need to instantiate our enable also, where we can say that enable is going to be 1. However, we really don't care what the enable is here, since our reset is already 0. Okay, so since our reset is 1, so we say reset is 0, our D is 1, so we expect to say a D of output of 1 after 1 clock cycle, and then we say that we have our D is 0. But this time, let's say our enable is 1, sorry, our enable is 0, and see what our output is going to be. We wait for 2 clock periods, we can say enable gets 1, and then we say let's wait for another clock period times 2. And that's it. So we're now going to run our code, and we're going to do that in the next video. So see you in the next video.